So we are proceeding with question number 2 in the topic of algebra. Let's see question number 6 in the advanced maths paper 2, advanced certificate of secondary education in the year 2025. Now let's see the solution part for these cases. Case A, we are supposed to show that logarithm of xy to base 16 equals to a half log of x base 4 plus a half log of y to base 4. So this was the proving part that we need to choose one side to show the other one. So here, through the laws of logarithms, now we can use the product law to show this expression here. And after showing now, hence, we are required to solve simultaneously the system of the following equations. Here we have the simultaneous equations that we are required now to solve. In case A now, so case A, the solution part required it to show it's a log of xy to base 16 equals to log, here is 1 over 2, sorry, here is 1 over 2, log of x to base 4, now you plus 1 over 2 again, log of y to base 4, base 4, so that is 4. Now if that to be the case, so we can just choose the left hand side. So from here, from the left hand side, that is log of x times y to base 16. Now we can choose this one. Now through the laws of logarithms, we know this we can extend it to be x to base 15. It means when you times, you add the numbers. So you add log of y to base 16. And this only exists if we apply the same base. So the sum of the same base, 16, 16 of different numbers equals to the product of those numbers with the same base, 16. From here now we can proceed by saying from the rule of change of base. So a base can be a number and a number can be a base. So here it is going to be like log of x now to the logarithm of 16. So base become a number. But all these now become with base 10, base 10, base 10. Now we plus log of y to the log of 16 base 10. So that's the rule of change of base. Now from here, so here we can say the rule of change of base. So a base become a number and we have the new base, that is base 10. Now from here, we can simplify here. So it is going to be log of x, then here we have log. But here because we have base 4, it means this now becomes the same as say 4 square. Now we plus log of y to the log, here is 4 square. Now taking it back from the power rule, so we have 2 log of 4, now we plus log of y 2, then log of 4. If that to be the case, then now we can proceed by saying 1 over 2 is constant, so we can just take it out. So it can be now, it's 1 over 2, then log of xc to the log of 4. We plus 1 over 2 again, log of y divided by the log of 4 is 10. When reaching at that stage, then we can go back to the rule of change of base. So here we're going to have 1 over 2, then log of x divided by log of 4 to base 10 now becomes log of x to base 4. Then now we plus 1 over 2 log, here becomes log of y, then base 4. Up to this point now we have shown. So we say we have shown this product of x and y to the base 16 in the same that expression here to the right. Yes. Now let's use now this concept now To solve the system of simultaneous equation that we are provided with given, is the log of x here y. Now 16 equals to 3.5. Then now logarithm of x to base 4, if we divide by the log of y to base 4 now equals to -8. So that is what we are supposed now to solve by the use of that law, the product law. So from here, maybe we can start with this part. Maybe here we term it as star 1, and here is star 2. So we can start with star 2. That's from log of x to base 4 is the same as say -8 log of y to base 4. So it means I've multiplied by log of y to base 4 both sides of this second star. So after getting that log of x to base 4 equals to -8 log of y to base 4, now we substitute this into star 1. So this maybe you can say star 3. We substitute it to star 1 as substitution part. So now we can say, so that's, we can say this now log of xy to base 16. Now we use that notation expression 1/2 logarithm of x to base 4, we plus a half again log of y to base 4. So we use this. So we replace this one by the law now that equals to this much. But now this is the modified star 1. Now we say substituting such star 2, star 3 into the star 1, modified one. So we substitute here. So where log of x base 4 now, we just insert -8 log of y to base 4. So here becomes, it becomes now log of xy to base 16 is less more to a half. Here now we put, so we put the value here. It is -8 log of y to base 4. Now brackets, we plus 1/2 log log of y to base 4. But log of xy, the product of xy to base 16, we know it is 3/3.5. So 3.5 equals to, if we simplify here, or if we take 1/2 out, then now remaining having log y now raised to -8, we apply the power of, then now we plus log of y to base 4. So after reaching that part, so we say so if we multiply by 2 both sides, it means 3.5 times 2. Now we end up getting 7. Because 3.5 is 7/2. It means times 2, now we get 7. So we get 7 equals to the log. Yes, that's in reciprocal form. It becomes this way. Base 4. And now we plus log of y to base 4. So from here, it is 7 equals to, now you combine by the law of product because we have the same base. So it's the same as say log to base 4, now you multiply the numbers. So it is this one raised to 8, now you times y. So it becomes that way. So here becomes 4 equals to log of what now? So here it means is y -8, now you times y power 1. So multiplying the same base, it means we add the exponent. So it becomes -7. So it's the same as say y raised to -7, then to base 4. Now for we to get this y, we need to transform this logarithmic form into exponential form. And how now we start with the number y raised to next 7 equals to base, then raised to exponent. So this is exponent base number. So from here now, if we try to find the reciprocal, it will be y raised to 7 positive equals to 4 raised to 7. Now from here, if we apply natural logarithm again, it's the same as ending, like say, if the exponent will be the same, now we take the bases. So we say, now taking 1 over y equals to 4. So it means when you find the value of y, it will be equals to quarter, 1 over 4. So from there, we have got y equals to 1 over 4. Now for we to get the value of x, we go back here. It means from star 3, where we had log of x to base 4, which is negative 8 log of y to base 4. So here, now we substitute the value of y. So we'll have this negative 8 log y. Now it is 1 over 4, with the same as 4 raised to negative 1. So here end up getting 8 positive. And here is log of x base 4. If you want x now, you go again to exponential form. So it will be number x equals to base raised to exponent. So you'll end getting 4 times 4 times 4, 8 times. It means from the scientific calculator now, if we try to find its value, that 4 power 8 now become 65,536. 536, sorry. So it becomes 65, then 536. This one. So now therefore the value of x, it is this much. And the value of y becomes 1 over 4. Yes. And up to that point, we have solved the part A for the value of x and the y. Now let's see part B. Now, part B, we are required to use the principle of mathematical induction to prove that summation, case B, so required to prove summation from r equals to 1 to n, then r cubic equals to 1 over 2n, then n plus 1, then squared. The whole expression now squared. So we are supposed to use principle of mathematical induction to show such a thing. So principle of mathematical inductions always show the reality or the proof on the expressions that involves assumptions, or we can say hypothesis. So we are going to test whether the expression is true or not by using some assumption. Assumption number 1 always relies on assumptions. So number 1, we prove that expression is true. It is true for n equals to 1. And also number 2, we need to show whether it is true for n may be equal to another constant. Maybe we don't deal with constant number 1, we deal with the other constant. That's for n equals to k now. K is just a constant, and it's a positive one. So we need to show whether is that true for another constant apart 1. Then again, number 3, Also, we need now, if this accept now, we need to prove for n equals to k plus 1. So it means that the new constant, k plus 1, the consecutive for this n equals to k. So these are the three basic assumptions that normally principle of mathematical induction is governed on them. So if that to be the case now, we can use them now to prove. So if that to be the case, maybe now we can start to check whether it is true. The left-hand side solution and the right-hand side solution will be the same for n equals to 1. So maybe we can start by say, now by using the principle of mathematical induction. Now, testing for truth. When n equals to 1. So here the left-hand side, the right-hand side. So we can say when we sum, here r equals to 1, now we say if r equals to 1 up to n, so if it is 1 now, it means our n is 1, so we say that is 1 cubic. If it's the same as say 1 over 2 times 1, then 1 plus 1 bracket, then the whole thing squared. So here we'll have 1 cubic equals to, we know here we'll have 2 times 1 times 2, then squared. So we get 1 cubic equals to 1 squared. So this 1 is the same as 1. So you can see left-hand side solution is the same as right-hand side solution. It means here there is a truth between the two sides, left-hand side and the right-hand side. Now, if this exists now, we need also to prove if it is true for n equals to k, and finally we prove for n equals to k plus 1. And now we can see if all this works, it means now the left-hand side and the right-hand side of this expression, it is always true. So if that to be the case, now we say, let's prove now, test. So we still test for n equals to k. So you will have summation, here r equals to 1, then now here it is n becomes k, so it means here r cubic will be 1 over 2, then here we introduce k where n, then now we plus 1, then now squared. So this is for k, n equals to k. Now we need now to prove, or we say proving, now proving for n equals to k plus 1. So that's consecutive. If k is 5, it means k plus 1 will be 6. So here becomes the summation. Now here is k plus 1. So here we have r cubic. Or we can say k now plus 1, then cubic. This is the same as say r cubic when k plus 1 now equals to what? It means until we reach the last term, that will be the general term. It means the previous term was k. So we assume that here is the same as say we add that when r is cubic for k. For k, and now we plus the last term, it has to be k plus 1, then now cubic. So now we prove for this. So we perform some operation and manipulations until now we get something like this. This one here, sorry. Here is k. Until now we get something like this, where n now becomes k plus 1. And here k plus 1 plus 2, so we get k plus 2. So until we simplify until you get something that resembles that earlier expression. So from here, now we can substitute the value of this. So the value of this we know here. We go back here, okay? So that is a half k, then k plus 1. We know here it is squared. Now we plus that k plus 1, then cubic. Because here we assume r is n, which is k plus 1. That's why it says k plus 1 cubic. And this is the last term, the general term. So if that to be the case, then maybe k plus 1, here we can say it is 1 over 4. Or we say, yeah, 1 over 4 this way, because we apply that square to every base. So k squared times then k plus 1 squared. Now we plus k plus 1 cubic. Then now we can factor out k plus 1 because it's common. It's happened here and here. We can factor out k plus 1, then made squared. So here what remains? It remains this 1 over 4, then k squared. This cancel out. Now we plus, here it remains k plus 1. Because we have factored out k plus 1 bracket square. So from there, maybe we can simplify here to see what we are going to get. K plus 1 square, then the LCM here is 4. LCM of 4 and 1 is 4. So here becomes k square. Now we plus k, we plus c. Sorry. 4 divided by 1 is 4 times this much. We get 4, then k plus 1 this way. So it becomes k plus 1 square. Then here is k square. Now we plus 4k, we plus 4. We divide by 4. So from there, you can see now how we do. So that is k plus 1 bracket square. But this one is a perfect square. If you try to factorize, you'll get the same factored square. That is k plus 2, now square, then over 4. So after getting that one, then now we proceed as follows. So that becomes k plus 1 squared. Now here, it might be k plus 2 bracket, then over 2. It means now this 4 is the same as, say, 2 squared. Now because they share the same exponent, it's the same as taking now the exponent out. So if that to be the case, we want it to resemble this expression here. So now we can say it becomes now k plus 1. Then now here is 1 over 2. Then now bracket k plus 2 bracket, then we introduce a square. So that square stays here. That's why we had 1 over 4. When it stays here, we have this one, k plus 1 bracket square, and the k plus 2 bracket is squared. Yeah, that's how we have it. So from there now, if it has brought this one, now we can say principle of mathematical induction works to show the reality of the left-hand side of this sigma notation and this right expression, that is true. That is true. So therefore, we can just say now summation for r cubic when 1 equals to r until n equals to 1 over 2 and then n plus 1 squared. Yeah, so that is proved. What nasema is true. Yeah, and proved under mathematical induction. Now, by the use of Cramer rule, the first thing that we need to know in case C, in this case C, use of Cramer rule, Cramer's rule. So what we need to understand in Cramer rule is that this is the method that employs or uses uses determinant of matrix to solve for the value of x, y, and z. And how is it done now? It means we just take, if we want the value of x, we take the second determinant, we divide by the first determinant. It means this is the original determinant of that matrix. And now when we take the new determinant, after replacing the values of x by the constant, then we have the new matrix where we obtain its determinant 2. Now we divide by the determinant 1. We get the value of x. But also y, it means the same thing. We replace all values of y in that matrix with the constant, with the value after equal sign. And now we find the second determinant. Then now we divide by the first determinant, the same first determinant, then we obtain the value of y. And the same applies to z. That's the second determinant by replacing values of z by constant. And now we form the new matrix where we can find determinant 2. Then you divide by the original determinant 1. Having done up to that point, it means now you have applied Cramer rule to solve for the value of x, y, and z. And that's sometimes this Cramer rule is also called determinant method, because 100% of its parts of the solution it employs these what determinant. And if that to be the case, now we have given the system of linear equations that 7x, if we plus y we plus z equals to -1, then x minus 3y plus 2z equals to 0, x plus 4y minus 3z equals to 4. So here we are going to express this matrix form, this system of linear equations in matrix format. And mind you, you have to arrange x's, y, z, then constant. So now already arranged. So you can say in matrix format, so we use coefficient of x here, 7, of y is +1, of z is 1. So here 1, -3, 2, and then 1, 4, -3. Now we keep the bracket. We have started with x, followed by y, followed by z, equals to the constant, -1, 0, 4. Now from here, we are going to let the square matrix equals to A. The square matrix that we have here is this one, where the matrix where number of row and number of column are equal. So this is the only square matrix that's present here. All these are not square matrix. So now we letting maybe A represents this square matrix, 7, 1, 1, 1, -3, 2, 1, 4, -3. Now after expressing up to that point, we find the original determinant, which is this, we term it as determinant 1. So we say determinant of matrix A now equals to what? So here we are going to apply that positive and the negative sign rule. And always mind you, it should start with positive, not negative. So that is how we find it. So if that to be the case, now we take +7 out. Then now we keep the determinant brackets. So this cancel out, the first row and the first column cancel out. So we remain with -2, 2, -3, 2, then 4, -3. So these are the elements that remain. We take -1 out. So we are going to remain the second column cancel and the first row. 1, 2, then 1, -3. We finish up with +1. So third column cancel and first row. So remain 1, -3, then 1, 4. Now we compute the determinant. So here becomes 7 times. This time this is 9 minus 8, because 4 times 2 is 8. Minus 1 bracket, and -3, we minus 2. Plus 1 bracket, This time that is 4 minus, this is negative 3, so it becomes positive 3. So now here we have 1 times this is 7, then negative 5 times this one is positive what? This will be positive 5. And here is 7 times 1, that is 7. So here becomes 14, plus this we get to 19. So that will be the original determinant. Now, you go back again. Now, start solving now the values of x. So we refer the concept that we take determinant 2, we divide by the original determinant 1 for this a. How is it computed? Determinant 1, it means now we replace all these values, coefficient of x, by the constant, if you're looking for the values of x. So here we plug -1 is 0, 4. Then now, these other coefficients for y and z, we just place them as they are. So 1, here is -3, here is 4, 1, 2, and the -3. Now we divide by that determinant 1, which was 19. So from here, now we solve for the new determinant. It means by the same idea of positive and negative sign rule. So the same idea we are going to apply. So we take out positive times this -1 is -1. So this cancel out, we remain with -3, 2, 4, then -3. Then here we minus 1. This cancel out, we get 0, 2, 4, -3. Then we finish up with positive 1. Now cancel, we get 0, -3. This cancel, then 4, 4. So that's what's remained over 19. So from there, now x becomes what? Here, it is -1 out. Then we get 9 minus 8. We minus 1 bracket, 0 minus 8. This and that minus that and that. So we plus 1 bracket, 0. We minus -12. That will be positive 12. All these divide by 19. So x becomes, this is -1. Now here we get positive 8. And here is positive 8. And here now is 12 over 19. So we are going to get, here it becomes 7. So 19 over 19, that is 1. So x now we get it is positive 1. Now we come to solve for y. That is the same thing. Determinant 2, replacing the values of y, because y is, that follows. It means the values in the second column are replaced by these constants. So values of x were 7, 1, 1, and now we have -1, 0, 4. Then we have 1, 2, then -3. We divide by the first determinant, 19. So here becomes the same thing, positive and negative sign rule. So the same thing that we are going to apply. So here we take positive 7 out. So we remain with 0, 2, 4, -3. Then we take out -1. It means now we plus 1. This cancel out, so we have 1, 2, 1, -3. Then we take out positive 1. So here becomes cancel, 1, 0, then 1, 4. Divide by 19. So from there, y becomes, here is 7 brackets, 0 minus 8, we plus 1, -3 minus 2, we plus 1, then 4 minus 0, over 19. Yes. So if that be the case, so the value of y becomes, here it is negative 8 times 7 is negative 56. There is negative 5 minus 5. There is 4, positive 4 over 19. So we are going to get negative 56 minus 1. Yeah, here because it remains, yeah, minus 1 over 19. So y equals to negative 57 over 19. So when we divide maybe 57 by 19, we get 3 negative. So we are moving for z. Now we are moving for z. For we to get z now, we need to replace the values of z by the constant. So these values, we take determinant. The values of x remain the same, 7, 1, 1. Values of y remain there, 1, negative 3, then 4. But for z, we put this constant. Now we divide by the first determinant. So the same thing, we go for positive and negative sign rule. So we take out positive 7. This cancel, the first row and first column cancel. So we remain with the element negative 3, 0, 4, 4. 4, 4. Then we take out negative 1 to mean the sign and the number. This cancel and that one. So remain 1, 0, then 1, 4. Then now we take positive negative 1 out. So this cancel and that cancel. We have 1, negative 3, then 1, 4 over 19. Over 19. So from here, we'll have 7 brackets. This is negative 12 minus 0. We minus 1 brackets. This is 4 minus 0. Then positive times negative is minus 1. Then 4, we minus negative 3, now we plus. Then over 19. Now z equals to what? So here will be negative 12 times this, we get negative 84. Here is 4, then we minus 4. Here will be 7, we minus 7. Because 7 times negative 1 is minus 7 over 19. So now on using the scientific calculator, negative 84, when we subtract 4, we subtract 4. We have negative 95. We divide by 19. So the answer now divide by 19. We end up getting z equals to negative 5. So having said that, now the values of x now become 1. The value of y become negative 3. And the z now becomes negative 5. So that is how we have applied Cramer rule to solve the problem. Now let's move now for part B. So let's see part B. Now in the expansion of bracket x squared plus 1 over x bracket raised to n, the coefficients of the fourth and ninth are equal. It means the fourth and the ninth term are equal. Their coefficients are the same. Now find the value of n and the sixth term of the expansion. It means here we are required to perform 2 things. That the activity number 1 is to find the value of n through the assumption that the fourth and the ninth coefficients of the fourth and the ninth term are the same. But also after getting them, it means now we know what is n. So we need also to find the sixth term of that expansion from that series. And that will be simple because already known the value of a. So case D now required to find the value of n, provided that coefficients of the fourth term, it will involve the concept of the binomial. So if it's involved binomial, coefficients are obtained by the concept of combinations. So it means coefficients of the fourth term is given by n choose the fourth. It means we go back one unit back. So it means n choose 3. That will be for the fourth, provided that this one and this one. And the coefficients of the ninth, it means we go back 1 unit. Ninth, it means 8. Yes. So provided these are known, are the same. Are the same. Yeah, are the same. So if these coefficients for the terms in the binomial expansion of that power series, they are the same, it means now n is very simple to find. So we can refer a solution. We refer that if n choose A equals to n choose B or n combination B, then now we say then it means A plus B is the same as n, or A is the same as B. It means when we add this A and B, we get that n. Or we can say A equals to B. It means A if is the same as B, it means A plus A is n, and B plus B is what? Is n. So here we don't know that because these numbers, A and B, are not the same. You can see here 3 and 8. So they are not the same. It means this and that, when you add, you have to get n. So what I can say now, then, from here, it means n choose 3, which is the same as n choose 8. Now, A may be 3 and B, it is 8. So they are not the same. So what next? It means now we employ A plus B will be equals to n. So it means n is the same as say 3 plus 8. N now equals to 11. So the value of n is 11. So the value of n there is 11. Now, if that to be the case, now for we to obtain the sixth term of the expansion, now we need to go for binomial expansion. So as you can see how the six terms look like. So now we can say from the binomial theorem, binomial expansion for power series, maybe A plus B raised to n. We know this is n choose 0, A power 0, A power n, then B power 0. Now we plus n choose 1, A power n minus 1, then B power 1. We plus n again choose 2, A n minus 2, then B square. We plus n choose 3, then A n minus 2, minus here minus 3 now. Yeah, so you can just look how the trend goes, okay? Minus 2, then here we choose 2. Then it means here now becomes B3. We plus n choose 4, then A n minus 4, then B power 4. If we count these terms, it means we've tried to write until we reach the 6 terms. 1, 2, 3, 4, 5. We end up getting now the 6th term. That is n choose 5, A n minus 5, then B power 5. Because here was 0, then 1, 2, 3, 4, here is 5. So it is decreased by 1 unit, the previous term, compared to the next one. So maybe we know now. So we can say now the sixth term, here, the sixth term of the series now is n choose 5, a raised to n minus 5, then b raised to 5. So that now will be the sixth term. Now from that sixth term, we are lucky that we know n, our n is 11. And what else? We need to know what is a and what is b. Now from this, from the notation now, expression, this one, we plus 1 over x raised to n. So here, our a, it is x squared, and b now will be 1 over x. So we just equating them. That this is a and that is b, and n it is what? 11, because n never changes. It is 11, formerly was here 11. Now, if that to be the case, so we can expand this to see how we plug them and getting that system. So through the help of binomial, we have managed to get the expression for the sixth term in that power series. So that n choose 5 is the same as say n factorial over n minus 5 factorial, then 5 factorial, if we can recall the formula for n choose r. So that's represent what? It means here I need to expand this until I reach n minus 5. So it has to be n, then n minus 1, n minus 2, then n minus 3, n minus 4, n minus 5 factorial over n minus 5 factorial, then 5 factorial. So you can see here, this n minus 5 and this n minus 5 factorial cancel out. So what has remained here, it is n, then n minus 1, n minus 2, n minus 3, until n minus 4. Then all these now you divide by the 5 factorial. So if that to be the case, now our n, we know it is 11. So we plug here 11. 11 minus 1, we get 10. 11 minus 2, we get 9. 11 minus 3, we get 8. 11 minus 4, we get 7. Then we divide by 5 factorial. So now let's see through the scientific operator, what exactly are we going to get? So bracket 10 times 11 times 9, 8, 7. Stop. No. 3 times 7. Now bracket. So we divide by 5 factorial. So we get 462. We get 462. So that is the value of n choose 5. The coefficients of that 16. If that to be the case, now already known. So what else? We need to know a raised to n minus 5. So now we can say a raised to n minus 5. A, it is x squared. Then now brackets, n we know is 11 minus 5. So we up and getting now, this will be 6, and now it will be x raised to 12. So the same apply to b raised to 5. B raised to 5, because that will be the 16. 1, 2, 3, 4, 5, 6. So b raised to 5 here. The value of b is 1 over x, now raised to 5. So this is the same as say x in negative 5. If that to be the case, then in that system, so n choose 5, a then n minus 5 times b raised to 5. So this will be equals to 462, that will be n choose 5, times a raised to n minus 5, that is x raised to 12, times b raised to 5, that is x raised to negative 5. So if we simplify here, we get 462, then times x. It means the same base now we add the exponent, the law of exponent for multiplication. So 12, when we plus with negative this 5, we end up getting 7 positive. So now the system of the expansion is 462 as coefficient, then x raised to 7. So that will be the answer. And up to that point, we have managed to solve question number 60, Advanced Mathematics Paper 2 in the year 2025. Thank you very much. Keep watching the next sessions.